So today we'll practice about the while loop and text document. Did you observe that one? So in the
Yes,
last, I given some practice examples.
yes.
So did you complete the practice? Do you get a chance to
Uh,
practice?
yes. Some only, Mahesh.
Okay. So so far everything is clear, right?
Yes, everything.
So today we'll practice about the while loop.
Hmm.
So far we practiced the if statement. All the if statement check the condition at once and executing the statements at once only, either true or false statement. So while statement is while condition, if condition is true, then statements will be executed. But in while loop, first control checks the condition. If condition is true, then only statements will be executed. After executing the statements, again control checks the condition. If condition is true, then once again the statements will be executed till the given condition is failed. Till the given condition is failed. Means they keep on executing the statements till the given condition is failed. Keep on executing the statements till the given condition is failed. Here I want to generate the values from 1 to 10. Here I want to generate the values from 1 to 10. So using the if statement, it is not possible. I can check the condition at once and executing the statements at once only, either true or false state. So here I am looking for conditional looping. Conditional looping. Looping in the sense iteration. Conditional looping statements are while loop, for loop, and do while, do until. First we'll practice about the while loop. In the while loop, first control checks the condition. If condition is true, then only the statements will be executed. After executing the statements, again control check the condition. If condition is true, then once again the statements will be executed till the given condition is failed. The flow chart look like this here. So this is the condition part. Here I am checking condition. If condition is true, then statements will be executed. After executing the statements, again control go for the condition part. If condition is true, then once again the statements will be executed. Keep on executing the statements till the given condition is failed. is a condition part here. If condition is true, then statements will be executed. Right. First, control check the condition. If condition is true, then only the statements will be executed. After executing the statements, again control go for the condition. If condition is true, then once again the statements will be executed. Keep on executing the statements till the given condition is failed. Like here, I'm trying to generating the values from 1 to 10. Here I'm trying to generating the values from 1 to 10. First, I'm starting the program, declaring the variable. Then I'm checking condition part. If condition is true, then I'm processing the statements. After executing the statements, again control go for the condition part. If condition is true, then once again the statements will be executed. Keep on executing the statements till the given condition is failed. Initial I equal to 1. I'm checking the condition part. I is less than or equal to 10. Then, so here I'm printing the I value first. Then I increment by 1 itself. I plus plus means I equal to I plus 1.
Mhm.
Then I will be 2. Again, control go for the condition. 2 less than or equal to 10. Condition is true, then 2 will be printed.
Plus.
Next, I will be 3. 3 less than or equal 10. Then 4. 4 is less than or equal 10. Then 5, 6, 7, 8, 9, 10. 10 less than or equal 10. 10 also will get printed. Next, I will be 11. 11 less than or equal to 10.
Oh,
Condition failed. Simply come out from the loop. So this is the way. So we are working the while loop. In the while, we can write the if condition. In the while loop, for loop, we can write the if condition. But in the if, it is not possible to write the while. Because while statement check the condition at once only, their true or false statement. And executing the true or false statement. In the while and for loop, in the looping statement, we can write the if condition. But in the if, it is not possible to write the loop. So here I'm print the 1 to 10 numbers. Here I'm writing the program. Main integer I equal to 1 while I less than or equal to 10. Then I'm printing the I value. I plus plus, let's close. So print even numbers up to 10, like 2, 4, 6, 8, 10. Hash include stdio.h. So integer I equal to 0 while I less than 10. First I'm incrementing the I value by 2. Then I'm printing the value. Printf %LD I value. Right. So here I'm writing the statements. I'm trying to generating the values from 1 to 10. Initial I equal to 1, 1 less than or equal to 10. Then I'm printing the I value. Then I plus plus I equal to I plus 1. I will be 2. Again control go for the condition 2 less than or equal to 10. Then 2 will be printed. Like this up to 10. Dot forward slash a dot out. The same way print the even numbers up to 10. I equal 0 while I less than 10. I less than 10 not equal to. I less than 10. 0 less than 10. Condition true. Then I equal to I plus 2. I will be 2. Then 2 will printed. Next again control go for the condition. 2 less than 10. Then 2 plus 2 4. 4 will be printed. Next 4 less than 10. 4 plus 2 6. 6 less than 10. 6 plus 2 8. 8 less than 10. 8 plus 2 10. 10 less than 10. Condition fail. Here if I'm writing the less than or equal to, the 12 also will come. But here I'm asking up to 10 only. So here I'm writing the less than 10 dot forward slash a dot out 2 4 6 8 10. So print odd numbers up to 10. Hash include stdio.h main. So integer I equal to 1. I'm starting at 1. I less than or equal 10. Then I'm printing the value first. Then I increment by 2 itself. Then close. The same way here I'm writing print the sum of the given series 1 plus 3 plus 4 plus 5 plus up to 10. Then initially I'm starting at 1 and value increment by 1 itself. The resultant value is sum. Resultant value is sum. See flowchart look like this here. See. The start button. I'm declaring the variables here input. Here just I'm assigning the value Then I'm checking condition part. If condition is true, then statements will be processing here. After executing the statements, again control go for the condition part. So here, initially I equal to 1, and then value is sum equal to 0. So I'm writing the condition part. I is less than or equal to 10. Then sum is equivalent to sum plus I plus plus. Then resultant value is sum. Initial I equal to 1, I less than or equal to 10, 1 less than or equal to 10, then I value will be added to sum. Sum equal to 0, 0 plus 1, 1. I plus plus I will be 2. Again 2 less than or equal to 10. Then 2 will be added to previous sum. I will be 3. 3 less than or equal to 10. 3 will be added to previous sum. Up to 10. 10 less than or equal to 10. 10 also will be added to sum. Then I will be 11. 11 less than or equal to 10. Condition failed. Come out from the loop and print the sum. Then stop. Right?
Mhm.
Got it?
Yes.
So hash include h main integer I equal to 1, comma, resultant value is sum. Any variable you can take, variable name. Input is not required here. While I less than or equal to 10, then sum is equivalent to sum plus I. Yes, I increment by 1 itself, so I plus plus. Then here I'm writing sum of series percentile d sum. In the same way, here I'm writing print the sum of 1 by 1 plus 2 by 3 plus 3 by 5 plus 4 by 7 up to 10 by 19. I value I'm starting at 1, j value I'm starting 1, I value increment by 1 itself, j value increment by 2 itself. But sum will be float, I integer, j integer. Integer by integer, result also will be integer, but sum should be in decimal. We are getting the sum value in the decimal. Hash include stdio.h, main, integer I equal to 1, j equal to 1, float decimal, right? Float sum equal to 0. Then while I is less than or equal to 10, then sum equal to sum plus I by j. I increment by 1 itself, so I plus plus, j increment by 2, j equal to j plus 2. 1 less than or equal to 10, then sum equal to sum plus I by j. 1 by 1, that is 1. Then sum will be 1, here I plus plus. I will be 2, j will be 3. 2 by 3. 2 by 3, 3, 0, 0, remainder is 2, quotient value is 2, 0. 2 by 3 is giving the 0. Some 1 plus 0, 1 plus 0, 1 plus 0. For 3 by 5 also 0, 4 by 7 also 0. Then how can I get the correct result here? So when I'm converting the I by j value into float, so here I'm writing the float here. This is called the typecasting. Friends, here I'm converting the integer value to decimal. This expression value here I'm converting to float. That float value will be added to sum. So we'll be getting the correct result here. Then printf sum of series percentile f then sum. Let's close. Like this here saying we're getting the sum of series 1 to 10. Dot forward slash a dot out. Sum is 55. The same way here writing the program hash include stdio.h. Next main integer I equal to 1, j equal to 1, then float sum equal 0, while I less than or equal 10, then sum equal to sum plus I by j, then I plus plus, then j equal to j plus 2. Then printf sum of series percentile f sum. We'll be getting the one only. cc file name dot c dot forward slash a dot out. Sum will be 1. It is not a correct result. So here I by j value here I'm converting into float. This expression value is converting into float, then getting the result. Yes, cq file name dot c forward slash a dot out. The result will be 6.06 something. So this is called the typecasting. It's called typecasting. The same way, print the mathematical table. Mathematical table in this format. 5 into 1 is equivalent to 5. 5 into 2 is equivalent to 10. Up to 10. Like it is a value. A into B is equivalent to
Yes.
input variable A only. Here initially I'm starting at 1 for B. I'm writing hash include stdio.h main input variable is A, B equal to 1. I'm reading the value for A, table you want. Scanf percentile D address of A. Then I'm writing the condition while B is less than or equal to 10. Then I'm writing percentile D into, I should get the format like this. Here I'm writing percentile D into percentile D is equivalent to percentile D. First percentile D, here I'm printing
Yeah.
A, second percentile D, B value, third percentile D, A into B, then A, B plus plus, then plus. I'm writing the program like this. V8 table.c, integer a b equal to 1. Which table you want? Scanf, I'm reading the a value. Then I'm writing while b less than or equal to 10, then so I'm printing the table values. cc file name dot c dot forward slash a dot out. Which table you want? Like this. A into b is equivalent to a into b. First percentile d in the program for a value, second percentile d for b value, third percentile d for a into b. Then I am incrementing the b plus plus. B value will be 1. So increment by 1 itself for looping purpose. Got this format?
Mm-hmm. Yes.
If I want to get the table in the reverse order, then I should start with b value is 10. Friends, condition is b is greater than or equal to 1.
B
Then
minus
b
minus.
minus minus. Next, factorial of a given number. 5 factorial is equivalent to 5 into 4 into 3 into 2 into 1. N value will be decremented by 1 itself. Resultant value is factorial. Input variable, only one variable is required here. So integer n, f is equivalent to 1, printf, enter a number, scanf, percentile d, address of n, is while n is greater than or equal to 1, and f equal to f into n. This n minus minus. Then factorial of a given number, percentile d, f, is close. The flowchart look like this here. Declaring the variables, reading the value, if condition is true, then only the statements will be executed. After executing the statements, again control go for the condition part. If condition is true, then once again the statements will be executed. Keep on executing the statements till the given condition is failed. n value f equal to 1. I am reading the n value here. Writing the condition. If n is greater than or equal to 1, if condition is true, then f equal to, initially f equal to 1, f equal to f into n, plus n minus minus. Again, control go for the condition. If condition is true, then once again the statements will be executed. Keep on executing the statements till the given condition is failed. This is the program. Now compiling it. This is file name.c dot forward slash a dot out. Phi value. Phi is greater than or equal to 1. Condition true, then 1 into 5, then n will be 4. Then again, checking condition 4 is greater than or equal to 1. And 5 into 4, the n value will be 3. 5 into 4 into 3, then 2. 5 into 4 into 3 into 2, then 1. 5 into 4 into 3 into 2 into 1, then n value will be 0. 0 is greater than or equal to 1. Condition failed. Come out from the loop and print the value. F value. Factorial of a given number. Factorial of a given number. Dot forward slash a dot out. Factorial of a given number. In the same way, here I am writing Fibonacci series program. Like 0 and 1, 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, and 3 plus 5, 8, like this, up to 10. We can give the limit also. In the same line, I want to get the result. Instead of using the line sequence \n, we can use the line sequences \t, tab sequence. We can use the tab sequence and to print the result in the same line. Right? So initially I am starting at a value 0, b value 1, c equal to a plus b. If the c value is less than or equal to range, that is 10, then I am shuffling the elements. A should becomes 2, 1, b becomes 1, a plus b, c value 2. That's 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 13 less than or equal to 10. Condition failed. Come out from the loop. If I am giving the 20, then so 20, 13 also will come. Right? How many variables we required here? A, B, C, and for range, n value. Hash include dev.h. Initially, I am taking the A value 0, B value is 1, C resultant value, n for loop, ranging. This printf, enter the range, scanf, %d, address of n, Now here I'm printing the A value. I'm not using the line sequence \n. We can use the tab sequence \t,
Okay.
tab sequence in B value. Then I'm writing C equal to A plus B. Now I'm checking condition. While C is less than or equal to N, then I'm printing the C value. Now, after printing the 1, here I want to print the 1 plus 1. Then I should shuffle the elements. A equal to B, B equal to C, C equal to A plus B. See, initially A equal to 0, B equal to 1. A will be printed, B will be printed. I'm reading the N value. Let us assume that here I given the 10 for N value. Here I'm printing the A value and printing the B value. Then I'm calculating C equal to 0 plus 1. C will be 1. I'm checking condition 1 less than or equal to 10. Condition true. Then 1 will be printed. This one will be printed. Next, I'm shuffling the elements. A equal to B. What is the B value here earlier? 1. Now A becomes 1. B becomes 1. B equal to C. Then C equal to A plus B. 1 plus 1. C
Plus
will
one.
be 2. Again, control go for the condition. 2 less than or equal to 10. Then 2 also will get printed here. Now A becomes 1. C becomes 2. 2. A equal to 1. B equal to C. That is B equal to 2. Then C equal to 1 plus 2. 3. 3 less than or equal to 10. Condition true. Then 3 also will get printed here. Next 2 plus 3, 5. 5 less than or equal to 10. Then 5 will be printed. Next 3 plus 5, 8. 8 less than or equal to 10. 8 also will be printed. Next 13. 13 less 5 plus 8. 13. 13 less than or equal to 10. Condition fail. Simply come out from the loop. This is a Fibonacci series program.
Okay. So Mahesh, is it mandatory to assign B as 1, right?
So here, if I want to get the result, then so like this here, we Fibonacci series, we are already we are fixing the output based on the output. Here I'm giving the instruction so that so
Okay.
initially A equals 0, it starts with 0 and 1. Then once initially we should get the two values, then I can get the series here 0 plus 1
Okay.
1, then 1 plus 1 2, then 1 plus 2 3 like this. So initially A equals 0, B equal to 1. Two variables here I'm taking.
Okay.
C is the resultant value, N is the range.
Range. Okay.
I'm executing the program here. CC dot forward slash a dot out. If I'm giving the range is 20, 13 also will get. The same way, so we'll practice about the greatest common divisor. GCD stands for greatest common divisor. GCD number program. GCD number program. Greatest common divisor program. Here I'm taking the two variables initially. Integer a comma b comma c here. Printf enter a b values and scanf percentile d address of a comma address of b, then c equal to a percentile b. Next here I'm writing c is not equivalent to 0, then a equal to b, b equal to c, c equal to a percentile b. then printf just a GCD number. Like for example here, A value I'm taking the 5, B value I'm taking 2, C equal to A percentile V, 5 percentile 2. C will be 1, right?
Mhm. Yes.
1 not equivalent to 0, then condition true. Then A equal to B, that is 2, B equal to C, that is 1, then C equal to 2 percentile 1. 1 2s are 2, remainder is 0. Friends, 0 not equivalent to 0, condition failed. So
Fail.
here B is the greatest common divisor. When I'm trying to, when I'm dividing the number with B, then we are getting the remainder is 0. So B is the greatest common divisor. GCD number is 1. Got it?
Okay.
You understand this logic?
Yes, yes. So like that we can find LCD also.
Yes.
Okay.
Dot forward slash a dot out. So find reverse number of a given number. Suppose here I'm giving the n value is 123, then reverse number should be 321. How can I find the reverse number? Whatever the number here I'm giving, whatever the number here I'm giving for n, for that number here I'm trying to display the reverse number. The last number should be separated. Then that number, last number here I'm adding to the reverse number here. Whatever the number I given here, that in that number last digit will be separated by dividing the number by 10 normally.
Oh, okay.
Friends, then first I'm trying to get the remainder here. N percentile 10, that is 123 percentile 10. We are getting the 3. Then I'm finding the reverse number. Reverse number initially 0. 0 into 10 plus remainder, that is 3.
30.
Then reverse number is 3
3.
initially. N equal to n by 10. The quotient value here I should take the, for looping, n value will be 12. N becomes 12. Again I am checking condition. So here n not equivalent to 0. That is 12 not equivalent to 0. Condition true. Then again reminder 12 percentile 10. Friends, now remainder is 2. Then reverse number already 3 into 10 plus remainder 2, 32. N equal to n by 10. 12 by 10. Reverse n will be 1. Again 1 less than 1 not equal to
0.
0. Then remainder 1 percentile 10. 10 0 0, remainder is 1. And reverse number is equal to 32 into 10 plus 1. That is 3 to 1.
320.
N equal to 1 by 10. 10 0 0, remainder is 1. Quotient value is 0. 0 not equivalent 0. Condition failed.
Fail.
Then reverse number is 3 to 1. For the logic,
Yes.
writing include stdio.h. Input variable is n, integer n, reminder, resultant value is reverse, initially it is 0, then enter a number, scanf, %d, address of n. Yes, while n is not equivalent to 0, then reminder is equivalent to n%10, when reverse number is equivalent to reverse number into 10 plus reminder, n equal to n by 10, yes, close. Then printf, the reverse number is equivalent to %d, reverse number, yes, close. Like this here. Declaring the variables, and reading the value, in the condition, if condition is true, then only the statement should be executed. After executing the statements, again control go for the condition part. Condition is true. Once again the statements will be executed. Keep on executing the statements till the given condition is true. So n, reminder, reverse number is equal to 0. I am reading the n value. Writing the condition part, n not equivalent to 0, and reminder is equivalent to n%10, reverse number is equivalent to reverse number into 10, plus reminder n equal to n by 10, then print reverse number. This is the flowchart. The execution is vi reverse.c, n not equivalent to 0, reminder is equivalent to n%10, the reverse number is equivalent to reverse number into 10 plus reminder n equal to n by 10. Compiling the program, reverse.c dot / a dot out. Here I am giving the n value 123, 1 2 3 4. Yes. So logic is clear, right?
Yes, Mahesh.
The same way, find a given number is palindrome or not. Reverse number is equivalent to given number, then the given number is palindrome. Once we read the n value, here, again I am storing b equal to n. B also having the 123. After completion of the loop, n becomes 0, right? After completion of the loop, here n becomes 0. So here I am taking the b. b is equivalent to reverse number. That is 123 is equivalent to reverse number. If it is same, then given number is palindrome. Otherwise, given number is not a palindrome. After closing the loop, again I am writing the condition, if condition. First, I should find the reverse number for this program. First, I should find the reverse number. Friends, then main integer n, the remainder reverse number is equal to 0, comma b. Then printf, enter a number, then scanf, %d, address of n, while n not equal to 0, and remainder is equal to 10% of 10, reverse number is equal to reverse number into 10 plus remainder n equal to n by 10. Then printf reverse number is equivalent to %d reverse. Then if b is equivalent to reverse number, then given number is polynomial. Else given number is not a palindrome. Dot / a dot out. Given number is palindrome. Logic is clear, right? Palindrome logic.
Yes, yes.
The same way, find the digit sum. Like 123, if I am giving n value 1 plus 2 plus
Plus 2
3,
plus 3.
then sum will be 0. That is the sum. In place of the reverse number, here I am taking the sum equal 0. Here I am finding the remainder, that remainder will be added to sum. Integer n, remainder, sum equal 0. Then I am reading the n value here. Enter a number, scanf, %d, address of n, is while n not equal to 0. Then first I am finding the remainder, then sum equal to sum plus remainder n equal to n by 10. Let's close. Let's printf sum of the series %d sum. Let's close. In the same way, find given number is Armstrong number or not. Cubical sum is equivalent to given number. 123 is equivalent to 1 cubed plus 2 cubed plus 3 cubed. That cubical sum is equivalent to given number,
Given
then
number.
given number is Armstrong number, otherwise
Okay.
not Armstrong number. Again here I am taking the b value. After reading the n value, here I am passing to b. So integer n, comma b, comma remainder, sum equal 0. The input variable is n. Enter a number and scanf %d address of n, then b equal to n, then while n not equivalent to 0, then remainder is equivalent to n %10, then sum equal to sum plus remainder into remainder into remainder, n equal to n by 10. Then printf sum is equivalent to %d sum. If b is equivalent to sum, then given number is Armstrong number. Else printf given number is not Armstrong number. Let's close. So this is all the practice about the
Okay.
while loop.
Mahesh, I have one question.
Yes.
When we are finding the sum of the digits, right? 1 plus 2 plus 3 equal to 6, example. So here also we are finding the remainder, right?
Yes, that reminder here I'm cubical sum here I'm giving. One
No,
cubed in the sense 1 into 1 into 1.
okay,
Cubed
no,
in the
no,
sense
not
2
in
into
the
2.
Armstrong program. In finding sum of the digits. Yeah. Okay.
Here I'm finding the remainder.
Remind.
123 divided 123 percentile 10. Then first remainder is 3. The 3
Okay.
will be added to sum. Then n
Okay.
equal 10 by 10. So n will be 12. 12 percentile 10. Then 2 remainder. The 2
Okay.
will be added to previous sum. 3 plus 2. Next n will be 1. 1 is that equal to 1. So 1 only. So here reminder that 1 will be added to previous sum. 5 plus 3 plus 2 plus 1. That is 6. N will be 0. 0 percentile 0. 0 not equal to 0. Condition failed. Then come out from the loop and print the sum.
So okay.
Right?
Okay.
The same way on some number.
Okay.
So I'll give some more examples for the while loop like yesterday. I've given the same thing here. I'm going to give some more examples for while. We can do the practice.
Okay.
We will see about the do while and for loop and switch case.
Okay.
So today what I explained the programs, everything is clear. Any doubts?
No, Mahesh. Everything good.
See you tomorrow. Okay.
Okay, Mahesh, is it possible to take classes in the evening time for Unix? If possible only.
Yeah, so that's what I want to discuss with you. The
Okay.
evening my time, so 10 o'clock
Okay. Fine.
possible for you or
Yeah.
5 o'clock?
Yeah. You 10 p.m. IST, right?
Yes.
Fine. Fine for me, Mahesh.
So your time zone, EST or
It's 11. EST.
EST? It's 11 in the morning, right?
11:30.
Yeah. So is it fine for you?
Yeah, fine.
Yeah. The 10, so today itself, so you can log in, right? 10
Oh,
p.m. 10
okay.
p.m. IST. Okay.
Okay. Okay, Mahesh. Thank you.
See you.